G'day, Tim Neale DataFarming. This is a talk I gave recently at the Summer Grains Conference 2023 on moving into digital agronomy. So I'm going to step you through some of the tools and techniques on how to become, particularly for agronomists, to get more into digital agronomy. I guess the main problem we're trying to solve as an agronomist is really about variability of production. You know, it's a really big underlying challenge in our farming systems. And this is a pretty typical yield map of a field showing some areas 4.5 tonnes per hectare of yield, and some areas only 1.5 tonnes per hectare of yield. So, you know, I've looked at thousands of yield maps over the years, and, you know, 300% is very common. So, you know, probably in this image here, there's most of those, well, all the red areas there would be totally unprofitable. So, you know, the good areas are sort of subsidizing the poor areas, and, you know, it's leading to a lot of inefficiencies as well. So most farms are still applying the same rate of fertilizers and chemicals across the whole landscape. And therefore, you know, that's a wasted expense and also not very efficient. So there's great opportunity here to increase productivity if we know what's causing these poor areas. There's an opportunity to improve efficiency and optimize inputs depending on the output or the potential output. And we've also got some, you know, reducing environmental footprint by being more efficient and effective. And things like nitrous oxide emissions from waterlogged soils with our applications of urea, for example, is a significant issue for the farming industry. So I guess, where do you start? You know, at DataFarming, we've created a really simple web application that you can use on any device, like a phone or a tablet or on your computer, that delivers satellite imagery anywhere in the world every 5 days for free. The reason we've done that is to really help people understand, firstly, what the variability is, and, you know, to really, you know, get a handle on that variation and what it might be costing. And of course, the next thing then is, how do I fix it? You know, what's causing it? How do I fix it? And, you know, satellite imagery is a really good starting point. It gives you a bird's eye view of your property, of your paddocks, so you can actually see that in real time. And we can go back to 2017, so you can get access to all that data for free through our DataFarming website. It's a really good entry point. You know, it's good for growers to experience as well as the agronomists to check their paddocks before they go out. So just log on to maps.datafarming.com, and basically you can upload your field boundaries and go from there. So really good starting point. We've created some tools like zoning, where you select the field. Once you've logged in, draw your fields, you get your satellite data, and once you've ground truth that, you can convert that into a zone map. So taking those images, if you like, and converting them into polygons, which we apply rates to, or add to rates, and then you can run that straight into a machine for application. So it could be, you know, in season fertilizing based on the satellite data. So, you know, in this case, the blue areas are the best parts of the field. They may want more or less fertilizer, for example. Another example could be, you know, these red areas could represent hostile soils that might need lime or gypsum. So you could use this map to then apply lime or gypsum in the off season as well. It could be, you know, weed densities or a whole range of things. So, you know, we're relying on the satellite imagery to convert to polygon, which will go into almost all new machines. So, you know, and we're making that really simple and easy. So just to go a bit more into the satellite imagery, it's an index called NDVI, which stands for Normalized Difference Vegetation Index. And it's a really commonly used index, but it picks up the red and the infrared light, which really brings out the differences, particularly in plant growth. So we get an image that looks like this. We color it up, but if you look at the red field in the middle, it might be a bit hard to see, but there's a field right in the middle. If we now zoom into that and clip that, and we re-stretch those colors just for that field, you'll clearly see now the differences. So that's the same image on the same day, but now we've stretched the colors for that field. And then, of course, you can just zone off that and add your rates and literally be going within a few minutes to get a variable rate application going. Obviously, the stuff we use is the sort of freely available data at 10 meter by 10 meter pixel, but we also sell high resolution. So we have deals with a lot of different satellite companies, and some we can get down to 30 centimeter pixel, but most commonly used, like in this vineyard here, is 50 centimeter by 50 centimeter on the ground. So like 400 times more pixels than the free data. And this gives you a lot more confidence in what you're seeing. Same sort of general impact, obviously, but just that real confidence. And in this case, there's obviously some water leaks coming out of the irrigation system, but you can see the good and the poor soils as well. So that's available at a whole range of resolutions from 50 centimeters to 2.5 meters. And that's all available on the website as well. So you can order this yourself, book the satellite. We book the satellites in, and we can capture multiple images over crops. And this is very popular with horticulture, tree crops, vineyards. And we also have a broadacre farming product as well coming online this winter season. The other thing that's really handy to do with satellite data is we can stack it together. So this is an image where we've taken step by step, we go through and we select the months and the images that you want to look at, and the user can do this themselves. And then once they're happy, we can squash all this together and you get a picture of what's the long-term productivity in each part of the field. And this particular example here, we did some soil tests. The black dots represent soil test sites. And very clearly, we could work out that it was a soil depth issue. Those red areas are very shallow soils, low in a lot of nutrients. So we're able to provide a variable rate prescription map to the farmer directly based on those zones. So all he had to do was add the zones to those, add the rates to the zones, and you've got yourself a prescription map. So I think really simple tools there for things like soil testing. This is particularly useful where you don't have any long-term yield data, for example, and you want to have a look at those long-term soil trends. Let's dig deeper, pardon the pun, into soils. We've developed and patented a thing called Rapid EM, which is a electromagnetic soil sensor. Now, EM's been around forever, right? It's not a new technology, but we've just packaged it up in a way that makes it really simple for anyone to do. We're trying to get it out to as many people as possible. We now have a number of these machines across Australia, and so you can hire them on a per hectare basis, and the data then is shipped up to the cloud, and we process that through the data farming platform as well. So not only can you see your normal resolution, your high resolution imagery, we now also see your soil mapping coming through. This machine measures down to 1.2 meters into the soil profile, and we've been doing EM mapping for 20 years. However, it just hasn't been widely accessible to other people. And just a quick point on this, I mean, in this map here, there's areas in the blue that have got significant subsoil constraints, acidity at depth, as well as lots of sodium in some parts of the profile, and salt. And that's what the EM is detecting. It's detecting salt and clay content and moisture content. That's all it's measuring. So you have to ground truth with some soil samples. But interestingly, we found these soil constraints, but there was 1,000 kilograms of residual nitrogen sitting in these blue areas because the crop had just not used it, and they've been applying nitrogen fertilizer for 40 years, and the crop just never used it. Whereas in the red areas here, the lighter soils with no constraints, there was no nitrogen left in the soil profile. So as an agronomist, if you took soil samples across this and say you got to an average of 300 kilograms because you got a bit in the 1,000, a bit in the 0, so that's your average, you'd say, oh, don't worry about nitrogen, there's plenty there. So this kind of tools, where you might have had field changes or those kind of things, where the stacking, the satellite imagery doesn't hold up, this is a perfect tool. And particularly if you're doing new developments, like new irrigation developments and new plantings of tree crops, for example, or you just want to get a better handle on what your subsoil constraints are. And this is driven about every 25 meters across the field. It collects data every second, and we can build some really nice detailed soil maps. This is an example of one of those, and there's some center pivot irrigators. The red areas here were like heavy clay soils, high readings, heavy clay soils. And the blue areas were the light sandy country, and you can see here where I've dug a hole. And the recommendation in this particular example, the agronomist walked into the blue areas, took a soil sample, and said, "You need lime." Now, that certainly was the case for these more acid sands in the blue, but all the red was highly alkaline and needed gypsum. So unless you have an understanding of the soil variability, very hard to recommend soil amelioration unless you get that understanding. And that's why EM is such a great tool to do that. So again, this can be booked through the DataFarming website, through the platform. You can book your own machine and we can deliver that in a box, and basically you can do your own EM mapping. I wanted to mention yield. Obviously, yield's the ultimate measure of the performance of the crop. And often, though, just keep in mind that this is a satellite image on the left and the yield map on the right. And, the image does a pretty good job of correlating with yield. Not always, but pretty good. And on the flip side, though, you can see quite a number of errors in this yield data, like the area to the far east there, sorry. There's a monitor error. You can see where the machine drove. There's gaps in the data. So yield is the best layer to have, but it's not always the perfect layer to capture. So just keep that in mind, and that's why the combination of these things works together really well. And here's just another example of, big yield variability. Some areas are less than 1 ton. These sandy rises here, there are acid sandy rises in this particular field, right up to the alkaline clay areas, doing over 3.5 tons. So 1 to 3.5 tons, on a single field, up to 5 tons per hectare. So, I think just understanding what those drivers are with a combination of, your soil testing, your biomass imagery in season, your variable rate zoning for different factors, and then measuring the final outputs and yield. Could be trial strips as well. Really good way of measuring that difference. So, yeah, I think that rounds it off really quite nicely. But this is what we're trying to solve. So thanks very much for listening. If you have any questions, feel free to reach out. This is our email and our website. And yeah, if you have any support problems with the web application, please email support@datafarming.com.au. Thanks again.